We are into chapter 5. Chapter 5 is all about systems of equations. We're going to look at a bunch of different techniques to solve these systems, the first of which is solving by graphing. So let's take a look at our first example here. First of all, a system of equations is a set of multiple equations, okay? And when we're looking at a solution of a system of equations, we're looking at do those graphs intersect and at the point that they're intersecting. So in example 1, it says tell whether the ordered pair is a solution of the system of linear equations. So what we have to do is we have to take this point and we have to plug in. So we're going to plug the point into both equations, and it has to be true for both equations. So obviously 2 is my x value and 5 is my y value. So we're going to plug it in for equation number 1, and we're going to see if it's true. So equation 1 is x plus y is equal to 7. So we're going to get 2 plus 5 is equal to 7. Is that true? Yes, 7 is equal to 7. So it works for equation 2, or equation 1 rather. Now we're going to do the same thing. We're going to plug in our x into our second equation. We're going to see if it's true for equation number 2. So 2, and then plug in your x value of 2 times 2 minus 3 times 5. Does that equal negative 11? 2 times 2 is 4. 4 minus 15, is that equal to negative 11? Yes, 4 minus 15 is equal to negative 11, so negative 11 is equal to negative 11. So it works for my second equation as well. So because 2, 5 works in both of these equations, 2, 5 is a solution. Let's look at example number 2. They happen to be both in y equals form here. That's perfectly fine. Let's see if it works. So we're going to try it in equation 1 first. I'm going to plug in my x and my y values. So my y value here is 0. So I'm going to get 0 is equal to negative 2 times negative 2, plugging in the x value of negative 2 minus 4. I'm going to get 0 is equal to negative 2 times 2 is a positive 4 minus 4. So I end up getting 0 is equal to 0. So it worked for equation 1. I'm going to try in equation 2. So I'm plugging my 0 in for y and my negative 2 in for x. So in equation 2, I end up getting 0 is equal to negative 2 plus 4. 0 is equal to positive 2. Obviously, this is not true. So it did not work for my second equation. It has to work for both of those. So negative 2, 0 is not a solution to this system. So keep in mind that has to work for both of them. We'll look at the try these in class. Let's look at our core concept here. Solving a system of linear equations by graphing. So if we want to solve the system here, we're not given the solution. We want to actually figure out what the solution is. In order to solve this, we're going to graph both of the equations in the coordinate plane, and we're going to look for the point of intersection. That point of intersection is your solution. We can check that solution by plugging it back into x and y into our original system. So let's take a look at this example. The good news for you here is that both of our equations are already in slope-intercept form. So we know that this is my y-intercept. And then this is my slope. So it's important when you're creating these lines that you create enough points to find the point of intersection. So I begin at my y-intercept, which is 5. And my slope is negative 2 over 1. So I can go down 2 over 1, down 2 over 1, keep going. I can go up and to the left. And I'm going to draw in my line. let's look at our second graph. Your slope is positive 4, and your y-intercept is negative 1. So you're going to start at negative 1. And now your slope is a positive 4. So we can go up 1, 2, 3, 4, and over 1. Continuing on, up 1, 2, 3, 4, over 1. Or we can go down and left. And we're looking at the point where these two graphs intersect. So obviously we can see that that point is right here. And that's our solution. What is that point? We're looking for the actual solution here. That is the point 1, 3. So 1, 3 is your solution here. X is equal to 1, y is equal to 3. If you want, you can check it by plugging into both of your equations. Take the 1 and the 3 and plug in for x and y respectively. So in the first equation, you're going to get 3 is equal to negative 2 times 1 plus 5, which gets 3 is equal to 3. So it works there because negative 2 plus 5 is 3. And then try your second equation. 3 is equal to 4 times 1 minus 1, which is just 4 times 1 is 4 minus 1 is 3. So you get 3 is equal to 3. So it works in that equation as well. Now, you have to be able to do these by hand, but keep in mind you do have the luxury of Desmos and using Desmos to help you. Now, you obviously won't have Desmos on a standardized test or anything like that, but if you wanted to check your work in Desmos, you certainly could. Go to your graphing calculator and plug in the two equations. So we have y equals negative 2x plus 5 and y equals 4x minus 1. So I've graphed the two equations in Desmos, and if I look at that point of intersection, I could see that the point of intersection is at 1, 3. Or try these in class, which we'll go through, including this example right in here, where you have 2x plus y is equal to 5 and 3x minus 2y is equal to 4. Obviously, in this equation here, you've got to go ahead and you have to solve for y. Get it in y equals mx plus b form first, and then graph your equation. Final example here is a word problem. It says a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase at the same price, the contractor buys 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. So we can set a system of equations here. We can say that shingles we're going to define as x. So x equals the number of bundles of shingles. And y represents the number of rolls of roofing paper. There are several ways in which you can solve this. I'm going to create two equations. So my first equation says 30 bundles of shingles and 4 rolls of roofing paper for $1,040. So our equation is going to be 30x plus 4y is equal to 1,040. And my second equation says 8 bundles of shingles. So 8x is equal to 256. There are several ways that you can solve this. You can solve for x right away because we have one of them. 8x is equal to 256. Divide by 8, and you would get x is equal to 256 divided by 8, which is 32. So you would know that I shouldn't say the number of, this is the price. So our shingles cost $32, and then you could take that 32 and you can plug it in here for x and get your y value. So 30 times 32 plus 4y is equal to 1,040. You would get 960 is equal to 960 plus 4y. I'm going to go over here now, subtract the 960. You're going to get 4y is equal to $80. Divide by 4, and you would get y is equal to $20. Okay, that's how you can do this, solving it algebraically. I want to show you graphing wise how you could have done this as well. So if you go to Desmos, you have your two equations, 30x plus 4y equals 1,040. So 30x plus 4y equals 1,040. And then you have 8x equals 256. So you're looking for the intersection point of these two lines. Oops. Eight x equals 256. So we're looking for the intersection point of these two lines, which we can see occurs right here, an x value of 32 and a y value equal to 20, which is what we got here. Y is equal to 20 and x is equal to 32. So if you wanted to, you can certainly graph the two equations once you have them written out. You can do that as well. We'll go through lots of practice in class, guys. See you then.